Hello and welcome. Today we are going to talk about section 4.7, use congruent triangles. Today's topic is mainly corresponding parts of congruent triangles are congruent, CPCTC. We talked about this once before at the beginning of the unit, but just kind of wanted to go back and talk about how we can actually form these different concepts. So CPCTC is really only used once you've concluded that the triangles are congruent, using any of the side, 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 or side angle, side, and so forth. So the basic steps, we look for vertical angles, and look for alternate interior angles, shared sides, different aspects of the triangle. You can also prove that the triangles are congruent then. And then whatever sides are missing, we list the corresponding congruency parts by CPCTC. Take a look at example 1. How can we prove that the following triangles are congruent? What other parts are congruent then by CPCTC? Well, if we look at the triangles, we can determine already that we have a side, an angle, and another side. Therefore, the triangles, we can name them triangle LKJ is congruent to triangle EFG by side, angle, side. So what other parts are congruent then by CPCTC? By CPCTC, which stands for corresponding parts of congruent triangles are congruent, we note the things that are not necessarily marked, such as angle E being congruent to angle L, angle G being congruent to angle J, and side JL being congruent to side EG. Example number 2. How can we prove that the following triangles are congruent? What other parts are congruent by CPCTC? Let's first take a look at how we can prove that the following triangles are congruent. Take a look, one of the first steps that we have to look for are things such as alternate interior angles, vertical angles, and shared sides. In this case, with this triangle, we have a vertical set of vertical angles. Based on this, we know now that we have an angle, another angle, and then a side. So, triangle LMN is congruent to triangle
At this time, all students who are remaining in the building for the afternoon, please report to the Commons for lunch.
Sorry for this.
At 12:15, at the conclusion of lunch, please report back to your testing room. Staff, you may drop off your testing materials outside of the counseling office on your way to lunch.
Now that we know that by angle, side, we can now start to prove the other congruences by CPCTC. Other congruences along these triangles that have not yet been named: angle L, congruent to angle P, side LM, congruent to side PO, and side MN, congruent to side ON. Again, we only use CPCTC after we've proven the triangle is congruent by one of the shortcuts, and we have to name another side or another angle that's congruent that we haven't yet quite named. For our last example, we are going to do a proof. Given that QK is congruent to QA and QB bisects angle KQA, we're going to prove that side KB is congruent to side AB. We're going to do this obviously using CPCTC, but first let's write our first two statements here. QK congruent to QA given QB bisects angle KQA, also given. Now let's take a look at the triangle. Now that we know that those two sides are congruent and that bisects, we can also determine that the angles, angle KQB, is congruent to angle AQB due to the definition of an angle bisector. Remember, bisect means to cut equally in two. We also know that side QB is shared within the triangles. So QB is congruent to QB using the reflexive property of congruency. Therefore, we can name the triangles congruent. So, triangle KQB is congruent to triangle AQB via side, angle, side. Since we've proven the triangle is congruent, any other congruencies based on side or angle would be CPCTC. So we can cut right to our last statement. KB is congruent to AB using congruent parts of, or corresponding parts of congruent triangles are congruent. This ends our notes. Please make sure that you complete the homework assignment associated with these notes and ask any questions that you might have in class. Take care.